So I'm going to talk a little bit about support specifically for the functions of archival selection and appraisal. So I use the word archival a lot, but I'm really talking about any sort of digital curation setting. Traditionally, cultural institutions, libraries, archives, museums, and it's been stated to be, sorry, I was just starting my timer. It's been stated to be very widely to be one of the most core functions of the work that people do in cultural institutions, this question of sort of what gets selected, what gets retained. And it's something that isn't necessarily very widely supported by software. And I'm going to talk a little bit about some what I would suggest to be very useful design principles, perhaps. Maybe that's too highfalutin a word, at least rules of thumb or heuristics, to be thinking about how to support these kinds of activities with software in general, but also natural language processing, machine learning technologies. Whoops, I need to select. As I've been saying, the real motivation for a lot of what I'm going to be talking about is that we've clearly made a lot of progress using the royal we here, right? I presume many of us are identified with some of the work that I'm referring to, have really tried to advance a lot of technologies. And compared to when I really entered this professional space of dealing with digital curation, more than 20 years ago, there was a lot of hand-wringing about things we needed software to do that it just didn't do it all, right? And I think we're much more in the space of having a lot of software, whether it was designed within the community or can be borrowed from elsewhere, that can be very beneficial in a lot of different steps, verification of files and identifying file formats and any number of things that we've essentially sort of routinized at this point, even though the processes can be improved, certainly. But this really fundamental activity of selection and appraisal, we don't necessarily have a lot of tools that, at least nominally, we don't call them tools for selection and appraisal and really kind of target them in our software development and our research and development activities. The decisions that are made are generally, I shouldn't use the passive voice there, the decisions that human beings make are based on different patterns. They identify ways in which these are a cluster of records based on certain functions, or, these are materials based on their aesthetic value that have a certain important continuing value to be retained. So we can identify patterns in various ways, and lo and behold, software is incredibly good at identifying patterns if you tell it which ones to look for, right? Show me all the dates. You can use some sort of regular expression and look for, credit card numbers or whatever it might be, or even higher level things like certain, communication patterns. Libraries, archives, and museums frequently want to take actions that reflect also contextual relationships. So a lot of the work that we do, I would say, is around sort of cultivating, conveying, exposing some of these contextual relationships that are present between different materials, right? And so that's really important to their selection and appraisal as well. A single email message, for example, out of a set of hundreds of thousands, without any thread, without any notion of where it came from or what it's related to, probably has very little retention value. But if it's related to other email that gives you the conversation, it can be much, much more revealing and much more valuable to retain. Compared to analog materials, and this is really my fundamental point from what I'm trying to convey today, is that compared to analog materials where selection and appraisal, even though it's still permeated around a lot of different activities, was essentially a function that could be seen as distinct. And because of the way digital materials reveal themselves to us over time, through the use of different tools, through exposure to different representations, my contention is, and I've heard this from a lot of colleagues going back, a number of years in these discussions, it's stuff that happens along the way, embedded in a lot of other functions, because that's when you learn enough to know whether this has retention value, whether it's sensitive and should be set aside, whatever it might be. So I would say a big reason why this is relates to, how I generally argue we should be thinking about digital materials, is that they reside at these different levels of representation. You could encounter them as aggregates. You can encounter them as sort of objects or packages that have different parts that come together. We can think of how they're rendered in software. Through the file system, think of just opening a file in Windows Explorer, and then you see things like, the last date that it was updated or things like that. not necessarily the actual date it was last updated, but timestamps that can tell us certain things. That's encountering it through the file system as opposed to as a file. You could have it as a file where you can open it in a hex editor and see all kinds of internal information. There can be sub-file data structures of like components of files. We can actually interact with it as it's coming off of a device and basically just read that bit stream, the ones and zeros, and write it out into a file. Even lower level than that, we can be detecting what the electronic signals are, if that's the case, because it's a problematic disk and we're trying to get the data off, for example. And then there's the actual physical medium itself. So essentially, just what I'm saying is engaging in activities, whether they're arrangement, description, preservation, reference services, any number of things. Professionals encounter the information, but perhaps at these different levels. And that's when we're actually able to reveal the sort of patterns and characteristics and attributes that'll tell us how long and whether things should be retained, whether they should be put into certain categories, for example. This has certainly been reinforced by some work that myself and a number of colleagues worked on called OSS ArcFlow, which was a project to look at workflows supported by open source software in a number of different institutions. And you could really see this fact that selection and appraisal kind of pops up in these different representations that we had of the workflows, right? Sort of a more narrative description, putting it into a table, breaking it out as a workflow, and you can kind of see the examples here. When I use the we, not our whole profession, but in these projects, I do want to point out that given the overview I'm doing here, I'm not really giving proper emphasis to all the people involved to this, but I do want to recognize that colleagues at the at MIF, Maryland Institute for Technology and the Humanities, the State Archives in North Carolina, Educopia Institute have worked with me on a lot of the projects that I'm going to be talking about. So one of the first forays, in a sense, into sort of somewhat larger scale software development work by the team that I've been heading up was this Bit Curator project. We created this Linux environment that has all these different tools that can support activities around getting data off of disks and reviewing them and finding sensitive content and all those sorts of things. And this was a two-phase project. We developed software. It's been quite popular, has a whole community around it. But what I'm really trying to emphasize here is that it's sort of an early processing tool. In the speak that many of us tend to use, it's essentially sort of a pre-ingest and partially ingest sort of tool, right? It's not a preservation environment. It's a set of tools that can be used to support various functions. And I think it really foregrounds the kind of design principles that I'm trying to talk about here, is that it's basically, I mean, it's an entire operating system environment that's been specialized for this work. And so it doesn't have a click here, then here, then here, then here workflow. It's essentially a tool set that can be picked up and used in different processes, which I think really affords this way of thinking about something like appraisal and selection being driven by levels of representation that we get exposed to over time. Whoop, I'm sorry, I just moved backwards. So the goals of the Bit Curator project were to essentially bring together a lot of open source software that already existed, build on top of that with additional sort of, duct tape code and other code that added actually really, very distinct additional functionality, and provide this in a way that could supplement what was already out there in the commercial sector. For forensics activities, for example, in law enforcement, we could draw from a lot of the tools and skills from there, but we wanted to make sure that it was more directly usable in these sorts of environments. The environment can be run again as a Linux environment, sort of as a virtual machine or as the only operating system on the machine, right? And it's being used in a variety of places. There's a lot of information on GitHub about this. And you'll see what we tend to convey being the supported functions of the Bit Curator environment: acquisition, reporting, redaction, and metadata export. None of these say selection and appraisal, but those sorts of judgments are actually built into a number of these different steps, because once again, the information is revealing itself. This is where you can find out much more about the software and the community around it, the Bit Curator environment. We then had a couple of follow-on projects, Bit Curator Access. I should say this series of 3 projects and then RATOM to follow it were all funded by the Andrew W. Mellon Foundation. So Bit Curator Access was basically to say people are using these tools to generate output from disks and other input into the system. What do they do with it now? And so this was the what do they do with it now project. We can provide tools so that they can access through a web browser. We can better support redaction so they feel more comfortable about what they are providing access to. And so that was also funded by the Mellon Foundation. We had things like this redaction tool that was developed out of the project, BitCurator NLP, as well as a browser tool to be able to access disk images. BitCurator NLP, then, certainly very relevant to today's discussion, was, again, responsive to what we were hearing from our partners and people in collecting institutions who were using the software to say, it would be very helpful if we didn't just have a way to sort of query and navigate through the contents of a disk, for example, that had been imaged. We want to be able to identify things that tend to matter to users of archival materials, people, places, organizations, which in the NLP world are named entities, right? And so that's something that our team could basically look out at the state of the art and say, what are the best open source tools? Are they reliable? Are they useful for our purposes? And then sort of package them up, provide training around it, allow people to use these tools in these sorts of environments. And so we have this kind of workflow, and a lot of this is just the sort of not very exciting nuts and bolts of how you enable something like NLP on something that comes off of a disk, right? First, you have to get the data off the disk. You have to know how to read the disk file file system. You then have to be able to read the files and pull text out of them. If it's a PDF file or whatever it might be, then you have to process that text, right? And so some of this work is just sort of the things in the back end that we wish nobody had to do to make sure that there's actually text that's readable in a clear way. And so this can then be fed into, for example, named entity recognition, topic modeling. And these were things that we worked on and provided tools around from this set of projects. So for example, here is a file from a disk, and you can see the entities that were detected on the fly using Spacey, which is a tool for named entity recognition. And then also topic modeling, so you can potentially infer relationships between materials based on their content. Following on to that, we had the RATOM project, which was looking at using natural language processing and machine learning to process email, to sort of review it for sensitivity, for public review, and also just to provide access to it and make preservation decisions. So these were the tools underneath. We had essentially two primary development paths. One was around creating this web-based iterative processing interface where you could select from a set of files and folders and look at the email. The other was this very sort of modular, I would say powerful, but I'm biased, set of tools for processing data out of email collections and pushing them into a database to be further processed in easy ways by natural language processing and machine learning. And so there's more information about that project. Our current project is called CARASCAP. Everybody needs an acronym, right? And it's about essentially better supporting review for sensitivity by those engaged in scholarly communication, scholarly products, research outputs. This is obviously a very active space, and I'd be happy to go into further discussion with people about the scope of that project, because obviously we're not the only ones looking at this, but we can talk more about that. Essentially, it's also trying to do what I've been talking about in these other projects, apply natural language processing and machine learning in ways that are kind of relatively quick, easy, and can give you results that are helpful for what you're trying to work on. So what I wanted to essentially conclude with are the points that I hope I haven't beaten too heavily at this point. But the first is the benefit of developing digital curation tools that can be inserted into different places into workflows. And that's something that the team that I've been so blessed really to have been working with over the past decade have really always emphasized this. We want open source tools that are well documented, that we've tested, adequately and have a community around them, hopefully, but that are also sort of reusable and modular enough that if you create something in this environment, some output, so for example, with RATOM, it writes everything to a very simple SQL-like database that can then be read by any number of other tools, right? So the idea is if you use these tools and your next step is to go into some other environment, you could potentially wave goodbye and never have to come back to the environment, right? It shouldn't be locked into that particular software set. The second thing is just this point that I've been making a number of times. Appraisal and selection appear in a variety of different archival functions. So I think they're really particularly amenable to this idea of modular adaptations and reusable sets of tools. And then finally, I would just say that natural language processing, machine learning tools should really be transparent and open for review and community contribution. I think, if you've read anything or seen any TV shows or movies lately about artificial intelligence, there's this incredibly active discussion around the level of sort of explainability and black boxness of, say, machine learning and how we should incorporate it into our lives. I think I can speak for our whole team to say we're very philosophically committed to the idea that there's no way you can do that well or responsibly as professionals if the way you're doing it isn't transparent and open for review by others. And so we've really tried to approach it that way. And I'll just conclude by saying we have a very small team, and we can't do an infinite amount of testing. So we rely very heavily on those who are interested in the software, who can pull it into the work that they're doing and give us input on it. So if any of the things I've talked about are useful for the work that you're doing and you want to bang on them and tell us how they're broken, we'd be extremely pleased. We love to hear how our software is broken. It's one of our favorite things to hear because then it gives us an idea of what we need to work on. So thank you very much. And I really look forward to the rest of the talks. I'm so glad to be part of this event.